Introduction. In this project, we are representing the muscular system with a simple model of the arm. We are imitating the movements that can provocate a cramp. Tension in the muscles are causing the muscle to extend and the cramp happens. There are chemical reactions happening at the same time at that, especially with calcium, that is the element in the bones. During muscle contraction, calcium ions are released from storage within muscle cells, which triggers the interaction between actin and myosin filaments, leading muscle contractions. ATP provides the energy necessary for the process. When the muscle relaxes, calcium ions are pumped back into the storage within the muscle cells, allowing the muscle fibers to lengthen.
Chemical process involved. The movement of an arm involves a complex interplay of chemical processes, but primarily relates to the contraction and reduction of muscles. This movement is controlled by the nervous system along with the skeletal and muscular system. Muscle cramps can occur due to various reasons, including dehydration, electrolyte imbalance, and muscle fatigue. First, the electrolyte imbalance, that means low potassium, is the low level of potassium in the muscle cells can lead to muscle cramps. Second, the sodium-potassium pump dysfunction. The sodium pump fails to maintain the proper balance of sodium and potassium ions across the cell membrane. The calcium influx. In response to the low potassium levels, there is an increased influx of calcium ions into the muscle cells. And the muscle contraction. The increased levels of calcium ions trigger uncontrolled muscle contractions leading to a cramp. This chemical imbalance disrupts the normal functioning of muscle cells, leading to the involuntary and sustained contraction characteristic of muscle cells, muscle cramps.
I'm Daniel Casanova. I am going to be explaining the operation of the model. So it's very simple. The model functions as some kind of pulley, that being a string, a string knot tied one extreme point to another of the model. So that way, when the arm extends like this, the string pulls the balloon like this. But when the arm narrows like this, it contracts, making the muscle expand, thus appearing bigger. So, specifically, um, the model had some particular changes for the presentation. For example, there was a lock added to the elbow so the strings could stay firm. In that way, let's say we were going to present the arm in a 90 degrees angle. So using the lock and adjusting it, the arm could stay in a 90 degrees angle. So that was about it of the operation of the model.
So, our model is expected to be a portrayal of the action of contracting a bicep when an arm is flexed. We imagine that it will be easier to express how a muscle contracts with our model as it simulates a moving arm, where a balloon, which consists in appearance is similar to a muscle, represents the bicep while the arm is moved manually with a rope. That is another advantage of our model, that you just need to pull a rope to show the process of contraction, making it simple to understand and explain by anyone. Also, it was created with recycled materials that can be found at home, so it is not difficult to recreate.
Conclusion of the team. Creating a model of the muscle system as a team is so relevant as the following showing activity that go well under visual representation. During this experience, we challenge of the following a functional model capable of stimulate the movement of a muscles, which requires significant laboratory and creative effort. The complex of actively dysfunctionally composed used to communicate effectively, share ideas, and solve problems together, thus strengthening your personal skills and your ability to work as a team. The constant interaction and the need to find joint solutions not only contribute to improving our understanding of muscular system, but also enhance key aspects such as resilience, patience, and adaptability. These skills are not only valued in academic field, but also extending of their daily life and professional environments when collaborating and problem solving are fundamental. And certainly, is the creation of a model of the musical system is a transcendence mere visual representation, acting as catalyst for personal growth and development of essential life skills such as flexibility, collaboration, shared gravity, ability to solve challenges together.